Welcome to the DelDOT training series on ADA compliance. This video will provide a discussion of several of the design considerations associated with pedestrian connections. Topics will include an introduction to DelDOT's design and layout criterion, pedestrian connection directionality, techniques to install the preferred perpendicular type curb ramps, pedestrian connection width, counterslope considerations, application of cross-slope requirements on alteration type projects, drainage considerations, and surface rollability. This video should be viewed after the first two videos in the pedestrian connection series have been completed. As demonstrated in the video on accessibility requirements for pedestrian connections, most accessibility standards have either a minimum or maximum requirement. Violating this criteria on new construction constitutes a violation of the accessibility standards. DelDOT design practice is to design and lay out facilities intentionally above the minimum or below the maximum standard to create an accessibility buffer. This allows for variability in the as-built features without violating the acceptance criteria. This approach is incorporated into the DelDOT Pass Manual and in DelDOT standard construction details. The accessibility standard for a curb ramp's running slope is 8.3% max. The department has adopted a 7.5% design and layout standard for curb ramp running slopes. This 0.8% difference between the accessibility standard and the design value allows for potential irregularities or variances due to construction methods or materials. Directionality is a critical element to consider during the design phase. To help people orient themselves to cross the street, pedestrian connections should be oriented so that the direction of the sloped segment creates a pedestrian pathway that is generally in line with the direction of the pedestrians travel through the street crossing. Pedestrian connections that align identically to the crosswalk are termed directional curb ramps. Providing properly oriented pedestrian connections reduces the amount of maneuvering that wheeled mobility users must perform to cross the street. It also assists individuals with vision impairments with orientation. This task is much more challenging at locations with larger radii as seen here. While there is no federal standard for directionality, designers should recognize that a pedestrian connection oriented in such a way that it points the user toward the center of the intersection, rather than the direction of the crosswalk, will be more challenging for users to navigate. Pedestrian connections can be made to be directional by rotating the slope segment of the facility relative to the curb line. This introduces a triangular area at the base of the ramp. The triangular area should be designed to slope toward the gutter flow line to reduce the potential for ponding. In practice, we see that a sighted user can navigate this location by traveling across the ramp. The relatively flat ramp slopes, side flares, and smooth transitions make this possible. This may not be possible in locations with steep slopes or with curb ramps that don't meet today's standards. The concept of pedestrian connection directionality must be considered in conjunction with the accessibility requirement to provide grade breaks on curb ramps that are perpendicular to the pedestrian's direction of travel. The designer is presented with two alternatives to coordinate pedestrian connection directionality and grade breaks to ensure compliance. Option 1. Place the grade break at the face of the curb. If this alternative is chosen, care should be taken to ensure that the clear space is contained wholly within the street crossing. This option provides acceptable directionality and reduces potential drainage and stability issues for mobility device users along the ramp. Option 2. Create a directional ramp by skewing the ramp relative to the curb line. This creates excellent directionality, but increases the possibility of ponding water and may cause stability issues for mobility device users. Designers should strive to balance directionality against the risk of creating ponding and challenging grade changes that could lead to a mobility device becoming unbalanced at the bottom of the pedestrian connection. Perpendicular curb ramps are generally preferred over the other types of pedestrian connections because of the desirable characteristics associated with their use. Perpendicular curb ramps are most applicable at locations where there is a buffer strip present or where the back of the pedestrian access route provides sufficient width to accommodate the development of a ramped segment that is perpendicular to the curb line. Curb extensions provide space for perpendicular ramps at locations with on-street parking. A curb extension makes pedestrians more visible to motorists. They also shorten the crossing distance and time of exposure to oncoming traffic. Here are two examples of shared turning spaces. Buffer strips and/or small curb radius make it possible to place two curb ramps per corner lined up with the sidewalks, with one shared turning space. At locations with steep grades, an approach curb ramp can be used to lower the elevation of the approach pedestrian path ahead of the shared turning space. The accessibility standard requires that the width of a pedestrian connection be a minimum of 4 feet 0 inches. However, design practice should be to match the width of the sidewalk or shared use path being served. The accessibility standard for counterslope is that the gutter or street at the foot of pedestrian connections be sloped no more than 5%. This accessibility standard is intended to reduce abrupt changes of grade, which may pose accessibility challenges to mobility device users. As a rule of thumb, the algebraic difference between the counterslope and the ramp slope should not exceed 11%. A technique to reduce an abrupt transition through the counterslope area is to create a 2-foot level strip behind the curb. The level strip area may include the top of the depressed curb and the required truncated dome detectable warning surface area. The accessibility standards allow for various cross slopes of pedestrian connections based upon the traffic control present at a location. On alteration type projects, the allowable cross slope will be influenced by the roadway profile slope, where the pedestrian connection meets the adjacent roadway and street level pedestrian crossing. Correcting the cross slope of the existing street crossing may not be possible within the feasible scope of the work on alteration projects, leading to cross slopes that may exceed the limits set by traffic control. Parallel curb ramps on alteration type projects will require that the cross slope of the turning space match that of the pedestrian street crossing where they abut. Depressed corners on alteration type projects will require that the cross slope of the bottom blended transition match that of the pedestrian street crossing where they abut. Perpendicular curb ramps on alteration type projects will require that the cross slope of the curb ramp match that of the pedestrian street crossing where they abut. Pedestrian connections are to be built to be ADA compliant to the maximum extent feasible. That will require creative grading to make a facility as accessible as possible. However, the turning space is not an element that should be compromised. Navigation in wheeled mobility devices is made more difficult when an accessible turning space is not provided. This principle, in combination with the requirement to provide a flush connection, means that all required cross-slope transitions will need to occur on the ramped segment. Rapid cross-slope transitions could create instability for some users. Therefore, it is desirable to make the cross-slope transition as gradual as possible and should not exceed a cross-slope transition rate of 3.0% per foot. Here we see some loss of wheel traction and sliding as this pedestrian tries to maneuver across an adverse cross slope. For constructability purposes, the cross slope transition should begin at the back of the truncated dome detectable warning surface. To prevent standing water at the base of pedestrian connections, locate the pedestrian connections and crosswalks away from a low spot in the road, place inlets upstream of the ramps, and establish a consistent flow line along the curb at street-level pedestrian connections to prevent sediment buildup. This may require additional paving be performed. Slope the top of the depressed curb within the pedestrian connection toward the gutter, and maintain a minimum 1% gutter flow line slope to support positive drainage. The surface of a pedestrian connection should be easily traversed by rolling wheeled mobility devices. Portland cement concrete will provide a smooth and easily traversable surface. Textured surfaces, like brick pavers, make the ramp segment harder to climb and less accessible. Use of textured surfaces should be avoided. We hope you found this video helpful in explaining several of the design considerations associated with pedestrian connections. Please consult with DelDOT's ADA Title II coordinator for accessibility guidance on your project.